Good morning to all. Today we are here to discuss a case study and a method of non-destructive evaluation used in all the critical components that are being used in nuclear power plant. So let us take a quick uh, recap of what we have done in the last class. So we have studied magnetic particle testing as one of the non-destructive evaluation in the last class. I hope you all remember how magnetic fields are used in a component where a defect has to be detected. So as the name indicates, non-destructive evaluation is nothing but we are not going to destroy the workpiece when it is being tested. So there comes a small limitation in the magnetic particle testing because the component has to be or has to have magnetic properties. It has to get magnetized when it is supplied with electromagnetic induction. So there comes a small limitation where we cannot use when the property is ferromagnetic or paramagnetic. So to overcome this kind of things, we have something called as eddy current testing. So you have all learned in the higher secondary classes about electrostatics or electromagnetic induction rather. So where Faraday's law of electromagnetic induction is stating that when a metal piece is suspended between two strong magnetic fields, the metal piece starts generating electromotive force, and that electromotive force is nothing but eddy current. So how this eddy current is being used in detecting the defects in a steam generated tubes, which is used in nuclear power plant. Let us see in detail. Okay. So here we have three ABC coils where the alternating current flowing through the coil at a chosen frequency generates a magnetic field around the coil. So when the coil is placed close to an electrically conductive material, eddy current is induced in the material. So if a flaw is in the material or the conductive material, it disturbs the eddy current circulation. The magnetic coupling with the probe is changed and a defect signal can be read by measuring the coil impedance variation. So let us clearly understand with the small analogy. So you could see a picture here where the stream of water beautifully flows through the stream. So the current of or the velocity of this particular stream is stable up to where there is a deviation like a swirl, right? So when this stream gets disturbed by the swirl happens because of uneven surfaces available in the bottom of the river. So this can be easily detected with the naked eye, and we could come to a conclusion that the bed of the river is disturbed in this particular place. So this analogy is same here, where this metal surface or the specimen is having a small crack or a discontinuity that will disturb the signal of the eddy current that can be read or measured. So there will be an impedance variation. I hope all you know what is impedance. That is, impedance variation can be read. As discussed, if the probe and its magnetic field are brought close to that conductive material like a metal piece, a circular flow of electrons known as eddy current will begin to move through the metal like swirling water in the stream. So the eddy current flowing through the metal will in turn generate its own magnetic field, which will interact with the coil and its field through mutual inductance. So changes in the metal thickness, the defects like near surface cracking will interrupt or alter the amplitude and pattern of the eddy current and resulting in magnetic field. So this in turn affects the movement of electrons in the coil by varying the electrical impedance of the coil. So our objective is to identify the size and detect defects such as circumferential cracks, intragranular attacks in the steam generator tubes. So this is the steam generator tubes shown in the picture in a nuclear reactor. So the purpose of steam generator is to convert water into steam from heat produced in the nuclear reactor core. So they are used in pressurized water reactors between primary and secondary coolant tubes. So these are the probes that is used that can be fed into the tubes to detect the eddy current flow. So eddy currents from bobbin coils flow in the circumferential direction being affected by the presence of circumferential cracks. So eddy currents from pancake coils flow through in a circular pattern being affected by the presence of circumferential cracks. So it is very clear that the axial crack detection coil and circumferential crack detection coil is being distinguishedly shown here. So this is the flow of difference in impedance where you could see some cracks in the workpiece that goes up to the area which is detected is 3 mm. So this is seen about the tube crack in a scanning electron microscope, and so towards internal diameter and towards outside diameter is shown here, and the crack is very much visible that 100 micrometers the scanning electron microscope is viewed and the defect is very clear. So reliability of eddy current testing during an in-service inspection was evaluated by destructive evaluation of 2 defective tubes pulled from PWR steam generator. The plus point coil probe showed a better capability to detect and size not only a circumferential crack but also intragranular crack. Therefore, combined use of these probes would provide a more accurate status of steam generator tubing. So the efficiency of any nuclear power plant is majorly depending on the steam tower generator tubing. So I hope you understand uh, the concept of non-destructive evaluation method eddy current testing. So let us have a quick summary of what we have discussed today. So we have seen what is the purpose of eddy current testing, and we have defined very clearly with an analogy how eddy currents flow. So we have taken a steam generator tube from a nuclear reactor to find out the defect or discontinuity in the tube. So using eddy current probes, it is being measured and the impedance shows a difference where there is a defect, and this defect is again seen through various analysis like SEM, and it is confirmed that there is a defect, and this method is very interesting and it is very safe to use, and it is like when the material is conducting, this method is highly efficient to find out the cracks. Hope this case study will give you a small glimpse or a small knowledge about this eddy current testing, and more videos to come in the future. Thank you all.